do it. And what undoes a natural log is an e. So if I take e to the natural log of y, anytime you take e and raise it to a power of the natural log, those two things cancel out and you're just left with y. So ultimately, my final limit will have to be determined by taking the limit that I calculate using L'Hopital, and e to that limit is my final answer. So let me go through an example. These are definitely pretty long problems. Alright, so here I've got the limit as x approaches 0 from the right of x to the x power. Let's use direct substitution and see what that gives us. So, plug 0 in for x, you get 0. Plug 0 in for the power of x, you get 0. So this is an indeterminate form, 0 to the 0 power, so I can't calculate it. I've got to figure out how to use L'Hopital's rule. Alright, before I can use L'Hopital's rule, I need the form of L'Hopital's rule. So let's rewrite this. Alright, so what I'm going to do is I'm going to take the natural log of the expression that I'm trying to find the limit of. Take the natural log. What that does is it allows me to rewrite the power as a multiplier. So my function is now x times the natural log of x. Okay? So I've got the limit as x approaches 0 of x times the natural log of x. Let's use direct substitution. By the way, that's 0 from the right. Direct substitution is going to give me 0 times the natural log of 0 and the natural log of 0, there's an asymptote and the natural log function at 0, so the natural log of 0 is infinity. So I have this form, 0 times infinity, which is actually a form that we looked at in one of our earlier videos, an indeterminate form where we use the L'Hopital's rule in order to calculate it. So let's go ahead and take that form, which is the limit as x approaches 0 from the right of x times the natural log of x. And let's remember that with direct substitution, we got the form 0 times infinity. And let's take that and try to write it as 0 divided by 0 or 0 divided by infinity, either one. And so remember, the strategy there is to divide by the reciprocal. So I'm going to divide by the reciprocal here, and I'm going to write this as the limit as x approaches 0 from the right of the natural log of x divided by 1 over x. So that is an equivalent form. And now let's see which form that is. Whoops, sorry about that. So if I use direct substitution, I'm going to get the natural log of 0 over 1 over 0, which is infinity over infinity. So that's a huge accomplishment. We've now gotten it into a L'Hopital form, which means that I can use L'Hopital's rule. then I can evaluate this limit by taking the derivative of the top and the derivative of the bottom. So the derivative of the natural log of x is 1 over x. The derivative of 1 over x, you might want to write that as x to the negative 1 power to remind yourself, but that will be negative 1 x to the negative 2 power, or negative 1 over x squared. Let's clean that up. I'm taking a fraction and dividing it by a fraction so I can multiply by the reciprocal. And when I do, I'll get negative x squared over x, which is negative x. So now I have the limit as x approaches 0 from the right of negative x. I think direct substitution this time is going to give us the answer we're looking for. When I directly substitute 0 into negative x, I get 0. So that's not my answer. Remember, that is the answer to the limit as x approaches 0 of x times the natural log of x. Okay, that's what that is. If I were finding the limit of x times the natural log of x, my answer would be 0. But the limit that I was actually trying to find, the original question, was find the limit as x approaches 0 from the right of x to the x. And so remember, in order to get from this form to this form, we had to use the natural log. So now we have to undo the natural log. And we do that by taking e to the limit that we find, e to the power of L. And in this case, L was 0. So e to the 0 power gives me a final answer of 1. So that's the tough part to remember, is going back and undoing the natural log by taking e to the limit that you find in order to get your final answer. So that process works with all exponential indeterminate forms. And let me just review the process one more time. So the first thing that we did overall was we took the natural log of the exponential expression that we're trying to find the limit of, that's indeterminate form. Then we need to rewrite the power as a coefficient, which is one property of logs. So remember, if we have f of x raised to the g of x, and we were to take the natural log of that, then we could take the g of x and multiply it out front, like so. So that's step number 2. Step number 3 is to rewrite it in one of your L'Hopital forms and use L'Hopital's rule to find L. The limit of the expression that has the natural log in it. Then we need to undo the natural log by taking e and raising it to the power of L. Alright, so that's L'Hopital's rule. There are lots of different forms. We started with the form of 0 over 0 and infinity over infinity, where we didn't really have to rewrite anything. It was already prepped to go. And then we looked at 0 times infinity, infinity minus infinity, and then all of these exponential forms. So they all come back down to these two, which are the required forms for your L'Hopital in order to use your L'Hopital rule.